Yeah, welcome. So we are discussing about memory subsystem. So in the last lecture we have discussed a brief overview about the memory subsystem, and the topic we'll be discussing in this class is about cache memory. So we'll discuss a brief introduction to cache memory and what is the role of the cache memory in increasing the speed of the processor, right? So that we'll be discussing. Okay. So so as you know that processor actually it works much faster than the main memory. Okay, so processor can do things very fastly, but main memory cannot cope up with the speed of the processor. So now what happens, now the processor has to wait for a long period of time because for the main memory to complete the task and to return. Okay, and also main memory is away from the processor, so again the bus delay, all these things will also happen. So these things basically it create a bottleneck. Okay, and the speed of the main memory cannot be increased beyond a certain point because the circuit or the electronics by which the main memory was made, it is totally different. So its speed cannot be increased beyond a certain point. Okay, so in this context we are introducing a new memory, and this new memory is called as cache memory. Okay, so as you know that cache memories are high speed memories which are placed in between main memory and the processor, and the most frequently used data, or the most frequently, or what you say, uh, yeah, mainly it is the most frequently used data will be placed in the cache memory, or you can say the most frequently data are the data which is likely to be accessed in the future. Okay, such information will be placed in the cache memory. Okay, so that the processor need not uh, the processor can get the data very quickly from the cache memory rather than from the main memory. Okay, so the entire concept of cache memory actually it works on the principle called locality of reference. The entire concept of cache memory, it 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 actually works on the principle called locality of reference. So what is meant by locality of reference? First we'll try to understand what is meant by locality of reference. The concept of locality of reference says that if you take a typical program, if you take a typical program or a process or whatever it may be, there may be certain statements in that particular program or the process which are frequently used than the other statements. Okay, so maybe this say this is a particular program or a process. I'll call it as p1. Okay, say this process contains 100 lines starting from line 0 to line 99. Okay, but assume that these lines are getting used again and again, say from line 21 to 69. Okay, these codes, these set of codes are used again and again. So in that case, in that case the program is going to spend most of the time on these codes, on line number 21 to line number 69, rather than in the remaining part of the code. Okay, you may ask why the program is spending more time here. Maybe the reason may be like there may be a loop here. Okay, there may be a loop here, right? Or there may be a what you call a if condition, and you may be asking the user to again and again execute this statement. Okay, so the one of the common reason why certain statements should execute again and again means loops are the basic reasons. Okay, so now this is one example for locality of reference. Okay, so the concept of locality of reference says that in a particular program or a process there will be certain set of statements or data or instruction which will be more frequently accessed than the other other contents. Okay, so now if you have a cache memory, then in cache memory what you can place, this portion you can keep it in the cache memory, line number 21 to line number 69. Okay, why? What is the advantage of keeping this in cache memory? The advantage of keeping this in cache memory is now we know that for this particular process most of the time this particular process is going to execute these instructions. Okay, so whenever these instructions are required, the processor can get these instructions from the cache memory itself, so it can access it very quickly. Okay, so this concept is called as locality of reference. Okay, so the whole idea of locality of reference is, in a typical process, there will be some set of statements which will be more frequently accessed than the rest of the statement. Such statements are called as locality of reference. Okay, again, in this locality of reference there are two categories. One is called as temporal locality, the other one is called as spatial locality of reference. One is called as temporal locality of reference, the other one is called as spatial locality of reference. What do you mean by temporal locality of reference and spatial locality of reference, you may ask. Say for example, processor, say this is CPU. Okay, say CPU want to some particular process is in the main memory. Okay, some particular process is in the main memory, say process P1. Okay, from this, say this process P1, it contains, let us assume it contains several blocks of information. Okay, right, or several words of information. This, each line is one word. Okay, each line is one word, several words of information are here. Okay, now say that CPU is processor says that I want word 5 from process P1. Okay, so these words are numbered, this is 1 2 3 4 5, something like that. Okay, so processor says that I want word 5 from the process P1. Okay, now, now ideally the memory control unit should, what it should do, it should first check, it will first check whether the particular, what you call, whether the particular word is available in the cache memory or not. If it is not available in the cache memory, it will fetch from the main memory and it will keep it in the cache memory. Okay, but in reality what happens in the sense, the memory control unit, it will not pick up only this one word, rather it will pick up a block of words, Okay, CPU is asking only this particular word 5, but actually your memory circuit is not going to take only word 5, it will take one entire block. A block is a set of words. Okay, it will take this entire block and it will keep it in the cache memory. Okay, right, and then now the CPU can access 5 from this cache memory. Okay, right, but why the memory unit is doing like that, in the sense, because currently CPU is saying that it wants to access the word 5 of process P1, but it is highly likely that later it may ask the CPU may request the word 4, or it may request word 6. Okay, so this concept is called as spatial locality of reference. This concept is called as spatial locality of reference. Means it means word 5 and word 4 are close in terms of space. Okay, I mean they are placed adjacent to each other. Okay, so with respect to space, they are nearer to each other. Okay, so currently if the processor has accessed one particular word, then it is highly likely that it will access the neighboring words also. If the processor has currently accessed one particular word, then it is highly likely that it will access the neighboring words also. This concept is called as spatial locality. Okay, so instructions with address close to a recently executed instructions are likely to be executed soon. Okay, so currently if you execute the instruction which is at this particular address 5, then it is highly likely that again you may execute the nearby address 4 or 6 or 7. Okay, that is the reason why the memory unit picks up the entire block and keep it in the cache memory. So this concept is called as spatial locality. Okay, and coming to temporal locality, temporal means with respect to time. So at present CPU is saying that I want to access this particular word 5 of process P1. Now the word 5 of process P1 is kept in the cache. Okay, now it is highly likely that maybe after 1 minute or after 50 seconds, again CPU may want to access this same word 5. This concept is called as temporal locality of reference. That is, if a particular address is accessed by the processor once, then it is highly likely that it may again access it very soon. Recently executed instructions are likely to be executed again very soon. This concept is called as temporal locality. Okay, right? So if a instruction in a particular address is accessed, then it is highly likely that the neighboring address also will be accessed. That concept is called as spatial locality. Okay, right? And generally locality of reference means that if you take a typical process or a program, there will be some set of codes or set of statements which will be more frequently used by the processor than the rest of the code. Okay, so basically cache memory is taking advantage of the concept called locality of reference. Okay, why we are discussing locality of reference means because we are trying to understand how cache works. So how cache memory works, in the sense, actually cache memory is exploiting this particular feature. What feature? The you can call it as a feature or a behavior. Actually the concept of cache memory is exploiting this particular behavior, which is locality of reference, which happens in any program. Okay, in any program or in any process, right? So 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 cache memory is taking advantage of the concept of locality of reference, right? Okay, fine. So this is a brief diagram which shows like where cache memory is placed. Cache memory is placed in between main memory and the processor. Okay. Now, now when the processor issues a read request, okay, now the processor may ask for one word, as we already discussed. Processor may ask for one word, okay, and say that word is not available in the cache memory currently. Now uh, now the memory circuit will not take only that word, rather it will take the entire block. It will take a block of words and it will be transferred from main memory to cache. Okay, it will be transferred from main memory to cache memory. Okay, right? So later for example, say it has taken this entire block. Say the block contains 4 or 5 words. Okay, currently processor want to access say first word, but later processor may want to access fourth word. Okay, then at that time fourth word can be fetched from cache itself. At that time fourth word can be fetched from cache itself, so it becomes very faster, right? So this is the reason why a block of words is getting transferred from the memory to cache, even though processor requests only a particular word. Okay, because again it comes under the principle of locality of reference. Okay, here it is spatial locality of reference, right? Okay, right. So if you see cache memory, what it contains, cache memory contains some blocks of main memory. Okay, so the content of cache memory is nothing but it contains some blocks. Okay, some blocks. Okay, so block is nothing but a collection of words. Block is nothing but a collection of words. Okay, so cache memory contains certain blocks. Okay, but the size of the main memory is very big. So the entire main memory content you cannot keep it in cache memory. Okay, some portion of the main memory, some portion of the main memory will be available in cache memory. Okay, so these blocks, whichever the portion of the main memory that is available in cache memory, those blocks will be present both in the main memory and also in the cache memory. So those blocks, whichever the block which are available in the cache memory, those blocks are there in the main memory and also in the cache memory. Okay, so there should be some mapping function which connect the blocks of main memory with the block of the cache memory. Okay, so we'll be discussing about this mapping function later in the next lecture in detail. Okay, but this is for your understanding. Okay, at present you should know that what cache memory contains. Cache memory contains only information which are present in the main memory. Okay, and always cache memory contains blocks of information. What is a block? A block is a collection of word. So it may contain few blocks of information. Okay, so where these few blocks came from? These few blocks actually it came from main memory. Okay, so it means that the block is also available in the main memory. Okay, so so the point is, whatever available in the cache memory, it is also available in the main memory. But not the entire main memory can be available in the cache memory. Some part of the main memory will be available in the cache memory. So there should be a mapping function between the main memory and the cache memory. Okay. and how those mapping function works, all those things we will discuss later. Okay, and why it is mapping function in the sense, because if you want, if you update anything in the cache, then that should reflect in the appropriate place of the main memory, or appropriate word or appropriate location of the main memory. For that we need a mapping function. So you get it? So that is the reason why we need a mapping function. Okay, right. Now assume that the cache is already full. Cache is already full. There is no empty location in the cache memory. Now say processor is requesting one particular word. Processor is requesting a particular word. CPU is requesting this particular word, say word K. But this word K is not available in the cache, and cache is already full. Cache is already full, and word K is not available in the cache. Now what will we do? Now what should be done? Now you will you have to identify where is word K from the main memory. From main memory you have to fetch word K. Okay. After fetching word K, you have to keep it in cache memory. But cache is already full. So now you have to remove some blocks of the cache memory, and you have to make some room or space for this particular word. Okay. Again this word, in the sense, memory circuitry will not read only the word. It will take one entire block. Okay. It will take one entire block, and it will remove one block from the cache because the cache is already full, and this block will come there. Okay, so that is called as replacement algorithm. Okay, there are different replacement algorithms. Again, we will be discussing this in some other lecture. Okay, but this is just for your information as of now. There will be a mapping function from the main memory to cache memory. Similarly, there will be some set of replacement algorithm. Why is replacement algorithm means, if the cache is full, then and if the processor wants to access some particular word, then the entire block will be moved to the cache memory. Now the cache is already full, so some content of the cache memory should be removed. Okay, or some block of the cache memory should be, again it should be returned back into the memory, so that a room will be created, and here the whatever the word currently being requested by the processor, that particular word along with the entire, along not only the word, the entire block can be moved to the cache memory. Okay, so that's the concept. Right. Fine. So now we will be discussing something called as cache hit and cache miss. First we will be discussing cache hit, then we will be discussing about cache miss. So first of all, what is meant by cache hit? Cache hit means, say for example, processor wants to access some particular data. Okay, now now processor want to access some particular data. Okay, now first now for now first the control circuit, what it will do, it will first check the cache memory, whether the data is available in the cache memory or not. Okay, actually processor don't know the existence of cache memory. Okay, processor don't know that there is some cache memory is there, and because of that only speed is increasing. No, actually processor will say that I want data from this location. It will just give the address of the memory, that's all. It won't give anything else. Okay, now it is the job of the operating system, but the operating system, what it will do, first it will check in the cache memory. If it is in the cache memory, it will give, then only it will fetch from the main memory. Actually processor does not know all these things. Okay, right. Now what is cache hit means, processor want to access some location in the memory, but the operating system or the kernel, what it will do, first it will check the cache, whether the data is available in the cache or not. If the data is available in the cache, then that is called as cache hit. Okay, if the data is available in the cache, then that is called as cache hit. Okay, so data means what you want to perform, what operation you want to perform. Either you want to perform a read operation or you want to perform a write operation. When the processor want to perform a read operation and the data was available in the cache memory itself, means then that is called as read hit. Okay, and if the processor wants to perform the write operation, and the data to be written is available in the cache memory itself, in the sense, then that is called as write hit. Okay, okay, whatever the content you want to write, whatever the particular address location to which you want to write, that content is already available in the cache, then that is called as write hit. Okay, right. Fine. So when you perform a read operation, when you perform a read operation, if there is a read hit, okay, that is processor wants to read some data that is available in the cache memory itself, then just read that. Then just read that. You need not go get it from the main memory, because processor is looking for the data and that data is available in the cache. You directly read, and processor can access it very fastly because cache memories are high speed memories. Okay, so this concept is called as read hit. What is write hit? See, write hit means uh, now cache contains what? Cache contains a replica of the contents of the main memory. Whatever present in main memory, one copy of that available in the cache memory. Not the entire main memory, some portion of the main memory, a copy of that is available in the cache memory. Okay. Now write hit means CPU want to write something to the main memory. Basically, it wants to write to the main memory. Okay. Now the memory control circuitry or operating system first it checks the cache memory, whether whatever CPU wants to write to the main memory is that particular data, or is that particular data is available in the cache memory or not. Okay. If it is available in the cache memory, then that is called as write hit. Okay. If it is available in the cache memory, that is called as write hit. Okay. If you are, say for example, this is CPU, this is CPU. Okay. Say this is cache memory. Okay. So originally there is some instruction like x equal to 10. X equal to 10. Okay. This is cache. Okay, I am calling it as C. And this is main memory. Okay, main memory is big, but say this is main memory. In main memory also this x is available at some location. X equal to 10. Okay. Right. Now there will be a mapping function to map this main memory with the cache. That is fine. Now what we are discussing, write hit. Now say that CPU want to write in this x. It want to perform write operation on this value x. It want to make this x instead of 10, it want to make it to 12. That is the write operation, right? So for that, how it should do? That's what we are discussing. So first, what it should check? First the first the memory control circuit, it will check whether x is available in the cache or not. First that it will check, because CPU wants to write what CPU want to write something to x, but x is in the main memory. Here actually CPU want to write, not here, because CPU don't know even the existence of the cache memory. CPU wants to modify this main memory's x value to 12, which is a write operation. Okay. Now the memory circuitry, first what it will check whether x is available in the cache memory or not. Yes, it is available. If x is available, then that is called as cache hit. Okay, or in this case write hit. On x you want to perform a write operation and that particular variable is already in the cache memory, so that is called as write hit. Okay. Now how to perform the write? There are two ways. One is called as write through protocol. The write through protocol, what it says in the sense, originally this x is 10, right? Originally this cache memory x is also 10, main memory x is also 10. So the write through protocol, what it says in the sense, immediately whenever you change the cache content, immediately you should change the content of the main memory also. So initially this is 10, which we are making it to 12. Okay, x is equal to 10, and now the memory control circuitry is making this to 12. So while you are making this to 12, at the same time change the content of the main memory also. This also you make it to 12. Okay, this also you make it to 12, right? So whenever you make a, so first of all, whatever you want to write, if that content is available in the cache, then that is called as write hit. Okay, now what is write through protocol? When you update the cache content, when you write something to the cache, then at the same time you update the respective main memory content also, because there is a mapping function, right? There is a map between cache and the main memory and cache. Using this mapping function, you update the content of the main memory also. So that protocol is called as write through protocol. Okay. There is another protocol which is called as write back protocol or copy back protocol, which is quite opposite to that. The write back protocol or copy back protocol, what it says in the sense, now if you want to update x, finally our objective is to update the main memory only. Okay, whether cache memory is updated or not, that is secondary. Our objective is to always update the main memory. Okay, But the write back protocol, what it says in the sense, you whatever the change you want to do, you change only the cache. You don't change the main memory. Main memory, so x will be 12 only in the cache memory. In the main memory, it will be 10 only initially. Okay. Then when it will change in the main memory, it should actually change in the main memory, right? Then only the change becomes permanent or effective. Okay. So first, but initially we will be changing only in cache. We won't change in the main memory at all. Okay. Main memory will be 10 only. Okay. Then when will you change the content of the main memory? There is a question. So the answer for this question is whenever this block is replaced at one particular time, either the process will finish executing or the cache memory will fill. Then what will happen? This block should be returned back to the main memory. Okay. At that time only we will modify this x value. At that time only we will modify this x value from 10 to whatever the new value. In this case it is 12. So that protocol is called as write back protocol or copy back protocol. Okay, right? And whenever we use write back protocol, what we do in the sense, we use one particular bit. This bit is called as dirty bit. This bit is called as dirty bit, and this bit will set whenever there is some change happens in the cache memory. So here if you see previously x is 10, now we are making it to 12. So 12 is nothing but you are making a change. So whenever you make a change, the dirty bit will set to 1. The dirty it is called as either or modified bit. Okay. So I am calling it as db or mb. So this data, this dirty bit or modified bit, it will become 1. If it is 1, it means that some change has happened in the cache, and that should reflect in the main memory. That is the idea. Okay. So to summarize, whenever write hit in the sense, okay, if the whatever the CPU want to perform the write operation on a particular data, and if that data is already available in the cache, then we say that it is write hit. Okay. Now in write hit there are two cases. There are two protocols. Either you can go for write through protocol or write back protocol, which is otherwise called as copy back protocol. Write through protocol, what it says in the sense, whenever the processor updates the cache memory, immediately the main memory also should be updated. That is called as write through protocol. Okay. And write back protocol or copy back protocol, what it says in the sense, initially you just keep updating only the cache memory. Don't make any change in the main memory. Okay. But whenever you make any change in the cache memory, make the dirty bit 1. Make the dirty bit or the modified bit set. If the modified bit is set, it means that some change has made in the cache memory. Okay. And when this change will reflect in the main memory, in the sense, it will reflect once when the process finishing executing. Okay. If the processor is finished executing, then the entire thing should be stored in the memory, right? And returned to the hard disk. At that time, it will be returned back. Okay, at that time only the updated value will be returned back to the main memory. Otherwise, sometimes what will happen, cache will become full. If cache becomes full, then some portion of the memory, some portion of the cache memory should be replaced. So some blocks you have to remove. Okay. So if you are removing one of the block which contains a dirty bit, okay, then you have to then that particular block you have to write into the main memory also. Okay. Because that particular block dirty bit is set, which means that some modification has happened, and that modification will reflect in the main memory. Okay. So whatever the block which is modified in the cache, that should be modified in the main memory also. Okay. So that protocol is called as write back or copy back protocol. Okay. Now let us discuss about cache miss. What will happen if there is a cache miss? Say the processor is looking for a data, and the data is not in the cache miss. Sorry, the data is not in the cache memory. Processor is looking for a data and the data is not in the cache memory. Then we say it is cache miss. Again, the cache miss can be either read miss or write miss. Okay, that is when you want to perform a read operation. Say the processor want to perform a read operation on some particular address. Okay, so as I have already told, processor does not know even the existence of cache memory. Okay, so processor will just say that I want the content from this particular address. Right? Now the memory control circuit or the operating system will take over. Okay, but first they will check in the cache memory. Whether, say, processor says that I want the content of the location 2502. Okay, now the memory control unit or the memory control circuitry will take over, and it will check whether the instruction or the data corresponding to this address is available in the cache memory or not. First it will check that. If it is available, if it is available, it can be read. That's it, fine. But if it is not available, whatever the content the CPU is looking for, if that content is not available in the cache memory, then that is called as read miss. Okay, CPU want to read that content, but that is not available in the cache memory. That is called as read miss. Okay, so if the read miss happened, then what should, if there is a read miss, then what should happen? So after that, as the data is not available in the cache memory, the data corresponding to the location 2502 is not in the cache memory. Okay, then as it is not in the cache memory, then again the memory control circuitry will check it in the main memory. It will check whether that particular address content is available in the main memory or not. Okay, if it is in the main memory, then the desired word is forwarded to the processor. Okay, if it is in the main memory, then what will happen? The desired word is forwarded to the processor. Okay, but how it is forwarded? First it will be forwarded to the cache memory. From cache memory only it will be forwarded to the main memory. Okay, again here it won't forward only that particular word. The entire block will be forwarded to the cache memory, and from there the and from there that particular word will be forwarded to the processor. Okay, so this concept is uh, so this is what happens when there is a read miss. Okay, but there is another way also there. There is something called as load through or early restart. What it says in the sense, okay, fine, CPU says that it wants some content to content of 2502, but that is not available in the cache. Okay, now again checking the main memory. If you get it in the main memory, if that particular word is available in the main memory, then immediately transfer that word to the processor. Immediately transfer that word to the processor. Don't first transfer the block to the cache and then transfer the word to the processor. That is a slow process, right? So the second method says that once you find the word, just directly send it to the processor. Okay. After that, you may move this word to the cache memory. You may move the entire block to the cache memory. So that policy is called as load through or early restart policy. Okay, right? So the concept of early restart policy, what it says in the sense, the desired word may be forwarded to the processor as soon as it is transferred, without waiting for the entire block to be transferred. Right? Okay. So when the data you request, or the word you request is not available in the cache, what happens? The memory circuitry will fetch it from the main memory, and from main memory it will keep it in the cache. Again from here that particular word will be given to the CPU. Okay, so that is the first case. That is the first case, this case. Okay, but the second case, what it says is you may also follow load through or early restart policy. What does it mean? CPU asks some content that is not available in the cache. Now the memory circuitry unit will check for that content. Once that word is available, just send that word to the processor, so that processor gets the content immediately. Okay, after that, if you want, you can identify the block of the data and move to the cache memory. Okay, so immediately sending that particular word to the processor, that concept is called as load through or early restart. Right, so this is what happens when there is a read miss. Okay, and what will happen when there is a write miss? Say for example, CPU want to write some content to the cache memory. Okay, say CPU want to update the value of variable a. Okay, but say variable a is not available at all in the cache memory. It is available only in main memory. The variable a, it is available only in the main memory. It is not available in the cache memory. This is main memory. Okay, it is not available in the cache memory. Okay, now CPU wants to write something, update the value of the a. Previously a's value is say 5. Now it want to make it to 10. Again memory control unit, first where it will check? First it will check the cache. whether it is available or not, A it's not available, so it becomes a catch miss. In this case, the miss happens while performing what operation? When the CPU want to perform what operation? Write operation. So we call it as write miss. Okay, write miss. So again, there are two ways to handle this. Whenever there is a write miss, what the memory control unit will do in the sense, uh, it will it will identify that particular block in the main memory which contains that particular word a equal to 5. Okay, and then it will move that entire block. It will move that entire block to the cache memory. Okay, and now CPU can access that particular variable a from the cache memory. Okay, so this is called as, again this is called as write through protocol. Okay, write through protocol, because uh, I'm sorry. So the first method is write through protocol. Okay. So in write through protocol, what happens in the sense, say CPU want to write something. Say CPU want to write onto the variable a, but variable a is not available in the cache. Variable a is not available in the cache. Variable a is available only in the main memory. Variable a is available only in the main memory. Okay. So write through cache, what it says in the sense, the memory circuit will first check cache, a is not available. So the write through protocol, what it says in the sense, you just directly update a in the main memory. Okay. Previously a is 5, you want to make it 10, directly update in the main memory. Nothing like bringing to the cache, all those things. So that is called as write through protocol. Okay. Whereas what is write back protocol says in the sense, now also there is a cache miss. CPU want to update a value from 15 to 20, but a is not in the cache. So now the write back protocol, what it says in the sense, the block containing that particular content a, that entire block should be moved to cache memory. First move that block to the cache. Okay. Okay. Then overwrite that word. Which word? A. Previously 15. Now make it to 20. So this concept is called as uh, write back protocol. Okay. In case of write miss. Okay. Right. So there is a write through protocol in write hit also we have write through protocol. Okay, so you should remember that. Here also we have write through protocol and copy back protocol, and in write miss also we have write through protocol. Okay, right. In write hit, write through means what? You are writing both cache and the main memory at the same time. Okay, you are updating the cache and also you are updating the main memory. Whereas in write miss, write through means some data you want to update, the processor want to update, that is not in the cache. So you are directly updating the main memory. That is called as write through. Okay, right. In case of write miss, write back protocol means the processor want to write some data, update some variable a, b, or c, but that is not available in cache. Now whatever the particular word to be updated, not only that word, the entire block will be moved from the main memory to the cache memory, from the main memory to the cache memory, and then that particular block around will be updated. That is called as write back protocol. Fine, let us stop the session here. Okay. Remaining will